Hi guys, we're going to do a quick lesson here on exponents, which is some review from 8th grade. And you may not have remembered all these rules, these exponent rules that we're going to go over, so figured we'd give you just a quick review on them so that it kind of refreshes your memory. Alright, so we've got multiplication of like bases, okay? So when we have exponents that have bases that are the same, and in this case, let me get my pen working here. In this case, the bases are a's, right? And there's a multiplication sign. As long as the bases are the same, we take the exponents and we add them. So, in the case of number 1 down here, if there are bases of 3's, and there's an exponent of 8, and remember parentheses, like when you have parentheses butt up against parentheses, that means multiplication. As long as these bases are the same, which they are, we're going to take those exponents and we're going to add them. So we get 8 plus 12 would be 3 to the 20th. And you're going to leave that answer. We don't actually, like it says in the directions, we're not actually going to calculate the answer. Okay? Let's go to 2. All right, bases are the same. They're both 4s. Perfect. Now, this first 4 has a 4 with a power of 1, or an exponent of 1. So, bases are the same. You don't change the bases. Don't change the base of 4. You're going to add the exponent. So 1 plus 6 is 7. Okay? Now, oh boy, I got 3 of them. No big deal. No biggie at all. Bases are all the same. 2, 2, 2. Right? All right, take a minute. Get an answer for me. Remember what to do. All right, let's see if you got the answer. Base is the same of all of them, right? 2, 2, 2, so my base is 2. I'm going to add these exponents. So 3 plus 4 is 7. 7 plus 10 is 17. Woohoo! Done. All right, now division of like bases. So that means if, remember when we multiplied, we add. So when we divide, we subtract. Okay? So let's jump right into this one. We got for number 4, bases are the same again. They're both 3's. 3 on the top, 3 on the bottom. So 3 to the 18th divided by 3 to the 7th. I think of this division as a big, giant minus sign. So then you're going to do 18 minus 7. So 18 minus 7 is going to be 11. So that's 3 to the 11th. And then we're going to do this next one for 5. We have a base of 23. So tell me what you think the exponent's going to be. I'm going to give you a minute. All right, hopefully you got it. You got 12 minus 1, which is 11. Okay, doing good. Now, bases for 6 are both 8. I've got 11 minus 11, I get 0. And anything to the 0 power turns to 1. All right? So, there's your division. There's multiplication, there's division. Now, let's do the power rule here. Base with a exponent raised to another exponent. So when we have what I call power on the outside to a power on the inside, we multiply those. Okay? So for this little yellow example here, notice that there's a power on the outside of m, power on the inside of n, and you multiply them. All right, so come to 7. Power on the outside to power on the inside. So 6 times 2 would be 8 to the 12th. Okay, so number 8, look at this one. Power on the outside to power on the inside. We have 8 times 0 is 0, and anything to the 0 power, remember what we said, is 1. Okay, and that's something that you did in 8th grade as well, but if you don't remember it, we'll talk more about it in class tomorrow, the 0 powers. So if you're confused about it, don't worry, we'll get you figured out on that if you don't remember. Okay, number 9, power on the outside, negative 11, to power on the inside, negative 9, so negative 9 times negative 11. Negative and negative are going to make a positive. 9 times 11 will be 99. So 3 to the 99th power. All right, and last one, negative exponents. Flip the base and make the exponent positive is the rule here. So if I have a negative exponent, okay, I'm literally going to put this whole power over 1, and then I'm just going to bring it to the denominator. When I bring it to the denominator, it makes the n positive. And at the opposite way, if the denominator has a negative exponent, like this a down here, I would bring it to the top, and then it would just be a to the n. So, looking at 10, I'm going to take that 10 to the negative third. It's on the denominator, and I'm going to bring it to the numerator. And that's going to be 10 to the third. And as soon as I bring it up to the numerator, it makes it positive. Okay? How about the 11 here? It is on the numerator, 5 to the negative 6. And the reason why it's on the numerator is I just made it a fraction, right? Okay, if I want to make it a positive exponent, I'm going to bring it to the denominator. And when I bring it to the denominator, it makes the 6 positive. And remember, you've got to put a 1 there as like a placeholder. Okay? All right, and last one here. Now, I do have inside parentheses a 1 to the negative 8. So, I'm going to bring that 1 to the denominator. Again, if there's nothing left on the numerator once you bring that number down, you keep a 1 there as a placeholder, just like we did over here for 11. When I brought the 5 down to the denominator, I had a placeholder of 1 there. So it still is, so it shows basically that that 5 to the 6 is on the denominator. And then I'm going back to 12 again. So I've got 1 over 1 to the 8th. Well, we can probably clean this up. 1 to the 8th power is like 1 times 1 times 1 times 1 times 1, 8 times. Well, 1 times anything is just 1. So this is basically 1 over 1, and 1 times again anything is just itself. So there's your 2 is your final answer. Okay? All right, quick review. It was under 10 minutes, so I was trying to make it really fast for you. So hopefully you have all these down. And we will talk more about this tomorrow. We're gonna go a little bit further than your 8th grade review with all this stuff, but we will go over these again. So we will see you then. Bye-bye.